Let's now create a similar example to what we had in the last video, just so that we can actually see this happening in practice. And just like in the last video, let's start by mutating a primitive value. So let's now use the last name, and I'm going to set it here to Williams. And so that's the initial value of this last name. Then let's also copy it. And so that's because let's say that this person gets married and decides to change their last name. However, we still want to remember the old name. And so we say old last name is equal to the current last name at this position of the code. But then we mutate actually the last name to Davis. So basically when this person gets married, they then change their last name to Davis. And of course, if we now check out both of them, so first the last name and then the old last name, then we see that they are in fact different. So Davis is the new last name, so the one that we mutated here, and Williams is this old last name that was copied right here in this first line of code, or actually the second line of code. So here everything works as we would expect in an intuitive way. Now remember that it works this way because each primitive value will simply be saved into its own piece of memory in the stack. Okay? But now let's do the same thing with an object, which, as we already know, is a reference value because it is going to be stored in the heap. And the stack then just keeps a reference to the memory position at which the object is stored in the heap. So let's create an object called Jessica. And so here we will have a first name of Jessica and a last name of Williams. Let's also give her an age of 27, just to make it more complete. And now let's again say that Jessica will get married and will therefore change her last name. And so this time, let's create a new object for the married Jessica. So married Jessica, and it should be equal to Jessica. So we're copying the entire object here. At least that's what it looks like. But behind the scenes, we are actually just copying the reference, which will then point to the same object. Remember that? And so now as we change the last name on married Jessica, so last name, let's change that to Davis. But as we already know, this will not give us the result that we expect. So before marriage, let's log this original Jessica object, so to say. And then after marriage, and then here the married Jessica object. Giving it a save. And now as we see, we get before the marriage and after the marriage, both the last name of Davis. All right. So the last name Davis is now also in the original Jessica object and not just in the one that we copied. And now at this point, we already know why this happened. So just to remember that, it happened because when we attempted to copy the original Jessica object, it did in fact not create a new object in the heap. So this one, again, is not a new object in the heap. It's simply just another variable in the stack which holds the reference to the original object. So both of these two variables simply point to exactly the same memory address in the heap. And that's because in the stack, they both hold the same memory address reference. And so of course, it makes sense that if we change a property on married Jessica, it will also change on Jessica itself. So again, because they are essentially just two different names for the same thing. Now, this is also the reason why we can change properties in the married Jessica object, which was declared using a const here. And const is supposed to be for constants, so for things that we cannot change. However, what actually needs to be constant is the value in the stack. And in the stack, the value only holds the reference, which we are not actually changing. The only thing that we are changing is the underlying object that is stored in the heap. And that is okay to change. That has nothing to do with const or let. All right? That's only about the value in the stack. But if we change something in the heap, that has nothing to do with const or let. Now what we can't do is to assign a completely different object now to married Jessica. So for example, we could not say married Jessica is equal to this new empty object. So that will not work, because this new object will be stored at a different position in memory, and therefore the reference to that position in memory will have to change here in this variable. And therefore that does not work, because that is in the stack, and so since it is a constant, we cannot change that value in the stack. So we cannot change the value to a new memory address, and therefore this does not work. If it was a let here, then we could do this, what we have here. But since it's a constant, again, it is not allowed. So as a conclusion, completely changing the object, so assigning a new object to it, is completely different than simply changing a property as we did here. Okay? So it's a fundamental difference, so please make sure to really understand this. Anyway, what if we actually really wanted to copy the object so that we could then change one of them without changing the other? So let me show you a way in which we can do that. Let's first add some comments here once more. So primitive types, reference types, and then let's now say copying objects. All right. And actually, let's create a new Jessica object. Let me, in fact, copy it from here. So let's say Jessica 2. And so now, if we really wanted to copy this object, we could use a function called object.assign. And what this function does is to essentially merge two objects and then return a new one. So we could do this, object.assign, and then again we can use this function to merge two objects. And so what we can do is to simply merge an empty new object with Jessica 2. And this will then create a completely new object where all the properties are really copied. All right, so the result of calling this function here with these arguments will be a new object. And so let's store that in Jessica copy. And now let's say that Jessica copy gets married. So the same situation as before, changing her last name to Davis. And now let's log both to the console just like here. So Jessica 2, and then here it's Jessica copy. So let's see what happens now. And so it's these last two here from line 222 and 223, right? And so now indeed we can preserve the original last name Williams after we change the last name on this other object here. So this Jessica copy. And what this means is that this object now is indeed a real copy of the original. So all the properties were essentially copied from one object to the other. And so behind the scenes, what that means is that a new object was in fact created in the heap, and Jessica copy is now pointing to that object. So it has a reference to that new object. However, there is still a problem, because using this technique of object.assign only works on the first level. Or in other words, if we have an object inside the object, then this inner object will actually still be the same. So it will still point to the same place in memory. And that's why we say that this object.assign only creates a shallow copy and not a deep clone, which is what we would like to have. So again, a shallow copy will only copy the properties in the first level, while a deep clone would copy everything. And to illustrate this, let me actually show you what I mean. And so let's add an array here in this original object. So an array of family. And this is going to work as an example because an array is really just an object behind the scenes. So here I can prove my point to you with this. So we have now an array called family, okay? And so you see that now this array here is indeed in both objects. So, okay, so far so good. But now let's actually change that array in Jessica copy. So in this one, because as Jessica married, she also increased her family. And so let's now add some more family members there. So Jessica copy dot family, and then let's use the push method to add a new element to the end of the array. And let's add Mary, and let's also add another one. So family dot push, and let's add John. So remember, here we are manipulating the copied object, which is actually a copy, but now here we are manipulating an object that's within the object. So that's this object. And so now as we save this, it still looks the same, but that's because we need to log, of course, after this operation happens. And so now we see that both the objects now have a family with 4 members. Let's open this a little bit, give it some more space. And so indeed, now before the marriage and after a marriage, the family has all these 4 members. All right. So the last name was, of course, as we already saw, preserved. So the name before the marriage is Williams, and that was preserved because that's in the first level, and object.assign here took care of copying that property. And so that was not changed as we changed the last name in the copy. However, the family object is a deeply nested object. And so therefore, object.assign did not really, behind the scenes, copy it to the new object. All right. So in essence, both the objects Jessica2 and Jessica copy have a property called family, which points at the same object in the memory heap. And that object is, of course, this array. And so when we change the array in one of them, it's also going to be changed in the other one. Now, a deep clone is what we would need here, but it is not easy to achieve. And it would actually be beyond the scope of this video to learn how to create a deep clone. Usually we do something like this, which is like really complex, using an external library, for example, like Lodash. And this library has a ton of helpful tools, and one of them is for deep cloning. And actually we will do that in a later section, just so you see how we can include an external library to do this kind of stuff. All right, and with this, we actually finish this section about how JavaScript works behind the scenes. And it was a long one with so many things and so many new concepts to learn. And many of them were hard and probably confusing, but that's not a problem. So it's always a part of learning. And even if you did not understand 100% of everything, you're still good to move on in the course to the next section now. But just reaching the end of this section already gave you a big advantage over many other developers which have no idea about many of the things that I showed you here in this section. So congratulations for sticking with it to the end and for learning all of this valuable knowledge. And now I see you in the next section.